Hello, everyone, and welcome to Wind Down Friday. Today, our special guest is Ahmad Bahai, a Senior Vice President and CTO of Texas Instruments TI. Hi, Ahmad. Welcome aboard.
Good morning. Welcome. Thank you so much.
Thank you. Thank you so much for your time. Where are you located, Ahmad?
Right now I'm in Dallas, but I go quite often to our Santa Clara Research R&D Center and also in Boston, which I am a part-time faculty at MIT.
Good. Thank you. So, Hamad, I have prepared for this Wind Down Friday episode a couple of questions to share with you. So you, as I mentioned at the beginning, you are CTO of TI, Texas Instruments. You also served different roles. You have had several leadership roles, including Director of Research Labs and CTO of National Semiconductor, but also Bell Labs, Algorex that you founded, I guess. So my first question, so what are the most valuable lessons you have carried with you through these journeys?
Yes, thank you so much, Maurizio, for the question. It's a privilege to have this opportunity to share my thoughts with you. As you pointed out, I have been involved in many R&D centers, and I was fortunate enough to work on the most prestigious research labs like Bell Labs, and then starting my own company, and then moving on to National Semiconductor as CTO and currently at TI. And what is exciting about this journey is that it was all about innovation and impact, how to come up with ideas that are really game changer in the sense that it can offer new opportunities that, really you can impact people's lives through technology, through the disruptive and innovative approach to technology. And when you see the whole process of how to inspire
Yeah.
and how to work hard on a concept with the intention of bringing it to the market with a big impact. That gets you going and that gets you moving every day. You get up with the inspiration, excitement, and passion and focus on what you think you can do best and offer a compelling solutions that people care about. So this connection of ideas to impact and what matters in people's life and customers' life really has been a common thread in my journey from the giant research labs to startups, all the way back to big companies.
Thank you. So now you are CTO of TI, Texas Instruments. So talking about your leadership style, so how has your leadership style evolved as you indeed moved from research labs to startup to also to leading, as you mentioned, innovation at TI. So and talking about needs in terms of customer needs, in terms of market, how do you balance breakthrough innovation with the practical needs of customer and in particular the market or markets?
Yeah, again, a very interesting question. There are multiple aspects to that. One is organizational, the second is technical, and third one is the
Mhm.
marketing and customer. On the organization, as you know, big companies have the strength of, the support, the infrastructure, the capability, the manufacturing. But at the same time, because of the size of the company, they have to care about, some of the key financials, the structure, and so on,
Yeah.
and work very carefully and methodically on that front. And for new ideas, sometimes you need to think out of the box, need to move fast, and need to kind of tie ideas to market and act on it very quickly.
Yeah.
So one of the big challenges of innovation for any big company is that how to create that agility, that pace of the innovation within the organization that is, quite well established. And what we came up with is that we can create these organizations, the small organizations within big companies, to act like a startup, move very fast, understand what the technology need and market needs are, and tie it together and work with the rest of the company very interactively and very dynamically. So we came up with this model of kind of building a startup like, and I emphasize on the like because you cannot make a startup within a big company, but startup like, meaning the agility, passion, excitement, talent, at the same time being dynamic and tying to the rest of the company. It takes some creativity. There's no formula for that. For each company is different, but we are very proud and excited that Kilby Labs in TI managed to create or build that environment of the innovation at the same time linking and tying and interacting very closely with the business units and product lines. So that's on the organizational side. On the technology and market, what I've come to understand over a couple of decades of the R&D across big and small companies is that it requires a top-down and bottom-up approach. And let me tell you what I mean by that.
Yeah.
Top-down meaning that there are markets that come to fast growth and fruition very quickly and exciting. For example, we saw many years ago or several years ago, the EV market that really started growing very fast. And we see that now AI is growing fast. So nobody can tell 10 years or 15 years from now which market is going to be the fastest growing. Of course, we can extrapolate some of the data we have, but things are dynamic because of the innovation. So market is dynamic. Technology is dynamic too, in the sense that you come up with a technology that nobody could even think of, or a new version of a technology that can change the world. I mean, a good example of it in power, that is area that you are expert and focus on, is like new materials like gallium nitride that all of a sudden became a kind of enabler in power. So the key in innovation is that tying those market trends to technology trends. And you cannot control all of them because many factors are in the play, but you need to always watch for opportunities and technologies that can impact those opportunities. For example, GaN was mainly, as you know, meant for high voltage, and it was looking for a killer app, and EV came as a killer app. And then people said that, oh, maybe data centers are the even more interesting killer app. And then it keeps growing. But then technology mapping to market is one of the biggest challenge that the technologies need to constantly monitor and watch, and making sure that you have the right tool set of technologies to address the market and customer needs that requires more innovative approaches.
So you mentioned a topic that is very close to my heart. So again, gallium nitride. So before asking you a question about this topic that I like so much. So talking about in general aspect from semiconductor industry. So the semiconductor industry is undergoing massive change in terms of AI, in terms of electrification, in terms of sustainability, in terms of renewable energies, smart grid, and you can add more. So moving forward, what do you see the biggest opportunities in this regard? Any particular challenges that you would like to mention before talking again?
Yeah, as semiconductor technology has some unique attributes that I think makes it very foundational for many applications, or I would say almost every application. What we have accomplished in semiconductor industry over the last several decades, I think is unparalleled to any other accomplishment. Think what other technologies manage to improve the performance millions of times, almost at the same cost. That is very unique thing that requires massive amount of intelligence and hard work and innovation at the material level, manufacturing level, device level, packaging level, design level, and so on. Everything from tools that are making these amazingly complex chips, and still we can afford these things on almost everything from simple things around you that are becoming more smart all the way to advanced data centers. So semiconductor, due to its accomplishment over many decades, has become so affordable and so powerful that can really enable capabilities that we couldn't even dream of just like 5-10 years ago. So what I would say is that this foundation role of semiconductor will continue for foreseeable future. Uh, the best example of it that look around you, how much electronics you're carrying. When you sit in a car, how much electronics you see in the car. I mean, the big part of the cost of any device is just electronics because you need
It
more and more electronics and displays and everything around that and intelligence and connectivity and so on. So this is going to continue, and that's why TI had this conviction and a strong belief that because of this growth of the applications and presence of the semiconductor in everything around us and affordability of semiconductor through scaled manufacturing, we have built a very unique infrastructure to address these trends. And of course, there are ups and downs. It's a cyclic market, but this cyclic market is modulated by exponentials, so it keeps going up and then have cycles on top of these exponential growth. So this is going to continue, and it's very exciting. I think there are many new areas that can leverage semiconductor even further. We see that, of course, the AI growth
Yep.
requires both on the cloud side and on the edge side, massive deployment of more semiconductors, from power to interface to processors for AI accelerators, memory, and all the supporting circuits around them. So this is going to grow both on the cloud side and on the edge AI. And I think edge AI in terms of units are going to be enormous. You can see that edge AI, everything from your car to the robots to
Yep.
your phones and desktops, all of them could play as an edge AI tool. And then we have extreme edge, which means your watches, your sensors, and everything else that's running on microwatts and milliwatts. So you can see that this massive level of intelligence across the different segments of the applications and industries, from cloud all the way to the edge, demands more and more of the capability on semiconductor. Another area that I think could be very interesting is that this concept of health-related semiconductor devices that are growing quite amazingly, in the sense that we see people both at the clinical level and at the wellness level wanted to use these devices to understand what's going on in the body. And a good example of that is this CGM, continuous glucose monitoring, that is becoming very hot. But there are many other applications that can become quite useful and potentially a big market. We see that wearables in general has potential to growth. Automation, autonomous system is another area that can even have more growth based on the capabilities that we can offer with new chips. So I would say next 10 years, we see even faster growth of the semiconductors in these new areas that can benefit from the capabilities and affordability of the new chips.
So TI has also made big moves in internal manufacturing, especially with the wide bandgap like GaN, as also you mentioned. We are talking about lateral GaN, vertical GaN, GaN on silicon, GaN on another substrate. So how do you see GaN evolving in this year to meet the growing power demands that you also mentioned in terms of application like data centers, AI workloads, and so on? How do you see GaN?
Yes, as you pointed out, uh, power and GaN has a lot of potential. And the reason that more than 10 years ago in TI, we started working on GaN with conviction that this technology can address a lot of needs in power management and delivery for the following simple reason. You need more power density across the board.
Yeah.
You can see that the data centers, each rack is going from couple of hundred of the kilowatts to megawatts. You can see that you need to squeeze more power in your smartphone, in your laptop. So even in adapters that you're using for daily life. So more power density and having it in a smaller space, delivering it more efficiently. So obviously that means we need devices that can offer this higher density, but Moore's law, as important as it is, was not enough to address the density, because when you go to the very finer node, you don't get the voltage you need to kind of like to for typical power delivery. I mean, let's say offline or some high voltage applications. I mean, usually those technologies thrive on 1 volt and below 1 volt, and you need kind of much higher voltage and capabilities. So we need a technology that can switch fast and handle high voltage.
Yeah.
That means wide bandgap. I mean, that's a natural thing. So that was a very common sense philosophy we used to spend time and investment on GaN technology for last decade. But as I said earlier, any new technology needs a new killer app that really makes it successful. And GaN and you never know that which market at what point is going to go through a step function of the growth. So you need to have the right technology for the right market at the right moment. And GaN was not as an exception. We developed the technology, and we are fortunate to see that now the smart energy, the AI centers, the EV market, all of these require more power density and a new material that can handle this power density. So these are all testaments to the fact that having a new device for high switching rate, high voltage was important. And that's why GaN even was more exciting than silicon carbide to me, because silicon carbide, of course, has an amazing capabilities, but GaN has higher switching capabilities for power delivery. Now, the challenge is, and you know that very well, Maurizio, when it comes to new materials, it takes a lot longer than what people think to make it manufacturable. You can prove the concept, you can have a transistor, a switch that is working fine, but in order to make hundreds of millions or billions of those devices at high performance, high throughput, high yield is not a trivial job. It's just, I always say that proving the concept is maybe 10, 20% of the road. Making it manufacturable at high scale is another 80% of the job. So we spend a lot of time to make sure that our GaN technology is manufacturable with high yield to make it affordable. And this journey is going to continue. So that's why we build the facilities, capabilities on GaN production. And we have every intention to address all of the markets that can benefit from GaN, from consumer to data center to EV to other applications, I mean, enterprise. And this technology, once we get even a better price match with silicon, we see even next step function of the GaN adoption. And GaN is growing very healthy now, and we are committed to offer the most competitive solution and capabilities from design to manufacturing, I mean, the fabs and packaging and covering the entire ecosystem of GaN technology.
Nice, thank you. So, Ahmad, you are also a professor of practice at MIT. Tell me more about this one. So, what inspires you about working with students? How how does that influence your work at TI?
Yeah, during my professional life, Maurizio, I always had one hand in universities. And the reason for that is, as I said, sometimes you need to get out of the box to think out of the box. So what I feel exciting about dealing with highly talented, top talents, young people with aspiration and ideas and very little regard for a status quo. They just want to do great things and they want to do next big great thing. And that is not only that doesn't not only helps you think big and think different, but also exposes you to fresh ideas that could be very important for your professional life in industry. Because, as I said, in industry, because of the charter of making a successful financial organization, you need to focus and you need to deliver. Sometimes you may miss the opportunities that are outside your focus areas that may impact your business down the road. And being outside among people who really thrive on new ideas and energy of, chasing new ideas and exploring these new approaches to the problems that you're facing can not only energizes you, but also exposes you to great ideas that could be very important for your next generation of products, your next technology that you're working on.
So you have spent your career driving innovation at the cutting edge of technology. So talking about technology, so is there one technology area you think is overhyped and one that is underappreciated in the industry right now?
I think during my relatively long professional, years of the work in R&D centers, I've seen multiple step functions in markets and
Mhm.
technologies that might be hyped at the beginning. That's the nature of a new step function, a new big technology disruption. And over time, this hype becomes more stable to the point that becomes a great tool or great capabilities, opening a lot of new opportunities. For example, I mean, that was maybe before my time, but the desktop was an example of the PCs. I mean, people were overhyped with PCs, but then what do you do with PCs? At the earliest stage, we were a little bit fuzzy maybe, but then over time, can you live without your laptop these days? I mean, that is becoming so over time it stabilizes and becomes an amazing tool. Then we had internet. In internet, we call it hype, right? Oh my God, internet is going to create a year 2000 kind of change. And this hype over time became such a powerful tool that every morning you wake up, you assume that you're connected to internet for everything you're doing. I mean, from your emails to everything, all the way to your washing machines. So the same thing we see in AI. AI now is so exciting. The AI journey started in late 50s. In fact, Minsky and McCarthy and MIT started first AI labs in 1959. The same year, almost the same year that Jack Kilby started, I mean, designed the first integrated circuit. So this journey has been going on. And when I saw the coincidence of Jack Kilby's and first AI lab in MIT about the same time, I see that this journey is kind of like two uh, prongs of
Yeah.
amazing technology journey that we went through. So recently, over the last few years, because of the processing capabilities, because of the availability of massive amount of data to connectivity, because of these new algorithms, we see that the big jump in the capabilities of AI, and obviously people get excited, and sometimes it translates to overexcitement. But that is an amazing capability that over time is going to impact almost every aspect of our life, as internet did, as desktop PC laptops did. And we see this journey has some overshoot and undershoot, but over time gets stable to the point that you cannot live without it. And to me, that is amazing opportunity for us in semiconductor industry in two ways. Of course, it creates a new market.
Mhm.
Look at what AI is doing. It drives the most challenging power management systems. It drives the most challenging highest speed optical interfaces. It drives the most challenging timing and clocking of these high performance systems and packaging and so on. So these are all new markets for semiconductor. But also AI is helping semiconductor market by enabling a more efficient design approach to semiconductor, a more intelligent EDA tools, more intelligent manufacturing for higher yield and throughput, more intelligent way of testing these things. And so it's a two-way street. I mean, semiconductor market is benefiting from AI growth or exponential growth, I would say, or unprecedented growth. But at the same time, AI enables semiconductor to become more efficient.
Mm.
So it's a very interesting two-way interaction between semiconductor market and AI growth.
So also talking about other sciences. So how do you see semiconductors also intersecting with the quantum biology or other frontier sciences in the future?
Yes, absolutely. As I mentioned earlier, I think biology and semiconductor are the two elements that working together, and they haven't worked together enough. That's
Mm.
why I started a center in MIT called Health Science and Semiconductor. And the goal of that is bringing capabilities of semiconductor to the future of health and life sciences. So as you know, in semiconductor industry, we try to keep things hermetically sealed so they don't get exposed to any liquids. And biology needs to be exposed to semiconductors, it takes a different approach how to
Mm.
expose molecules to semiconductors for different purposes.
Mm.
Could be in vivo, in vitro, could be different
Yeah.
applications of the life science and health science. I gave you an example of that, like CGM. So we think biology and life science and health science are some areas that can benefit from the innovations and success of semiconductor industry to make in making things affordable, and capabilities like processing, power management, interface connectivity more and more available to a wide range of applications in biology, life science, and health science. Quantum technology, there are two aspects to that. One is
Mhm.
quantum computing, and the other one is quantum sensing. And I think they are both very interesting. Of course, quantum computing is offering a different approach to computing, and it requires a massive number of the semiconductor devices, of course, because of its cryogenic
Yeah.
nature. For
Yes.
some parts of it, you need to have some specific devices that can perform properly in that environment. And but over time, we see that it becomes more and more uh, affordable in the sense that you can use it for more applications. Again, quantum computing shines in applications that by nature are less deterministic, and that is a wide range of applications from drug discovery to security and many others.
Yeah.
Quantum sensing also is equally exciting because we see that now we can offer much higher performances in some of these sensors using the quantum technology. For example, nitrogen vacancy quantum sensing for magnetics and things like that. So we see all these new areas are getting more and more not only exciting in terms of market, but also more available and more pervasive across multiple areas of the applications. And I think growth in these areas can also benefit the semiconductor market, both in terms of the business and innovation.
So thanks a lot, Hamad, for sharing all of this information. Very nice. So I have just the last one to close on a lighter note. So as the philosophy of Wind Down Friday, let's talk about a bit beyond you, beyond semiconductor, beyond technology. So when you take a step away from technology, so it's difficult. But what's hobbies? What's your favorite way to relax, to have fun? Tell us more about you.
Yes, it's interesting, and when you are into technology and you're excited and passionate about technology, sometimes it's hard to turn off the clock and say that, okay, now it's 6 o'clock. I don't think about technology anymore. Sometimes even when you're sleeping, back of your head, there's a new idea that in the
Yeah,
morning you
indeed.
wake up and say, oh, maybe I should write it down. So I don't think I can compartmentalize my life. That's okay. 8 to 5 technology, 5 to 10 no tech. I mean, it's kind of permeated. It permeates itself all the way. But as far as other activities, I really am a big fan of workout and exercise. And let me elaborate on that.
Sure.
Working out my body and my mind, and hopefully my soul. So on my mind, I really like reading books, especially books that are into history and biography of people who changed the world.
Nice. Yes.
And that gives me a lot of ideas, what went right, what went wrong, what worked, what didn't work. And so you need to build up the muscles in your mind almost on a daily basis to make sure that you stay fresh. And on your body, I mean, just I'm more excited about doing sport than watching sport, unfortunately. So I usually take every moment that I have to do some workout. And by the way, while I'm doing workout, I'm listening to audiobooks. So it's gonna help both minds and body at the same time.
You are combining both
That's
reading
right.
books and exercises.
That's right.
So thank you so much, Hamad. Thanks a lot for this time. It's been a pleasure. I got this honor to have you at Wind Down Friday. I wish you a great day, a great weekend, and stay in touch. See you next. Thank you, Hamad.
Thank you so much. It was a pleasure talking to you, and thank you for taking the time.
Thank you.